This is the experiment for lift, drag, and pitching moment of an airfoil. You've seen this wind tunnel before. In this case, what's different is that we're going to be using this force transducer that measures lift, drag, and pitching moment. In the test section, you can see that there is an airfoil that spans the width of the test section. It is 300 millimeters in span and the chord length is 150 millimeters. On the force transducer, you have the ability to adjust the angle of attack of the airfoil. Right now it's set to an angle of 0. What you're going to be doing is taking measurements starting at 350 degrees, incrementing the angle of attack in increments of 2 degrees until you hit 20. So to start this experiment, you're going to first turn on the unit and then come over to the computer and launch the proprietary software. The icon is labeled AF100 New Data. So as it comes up, you want to make sure to check the parameters that you're going to be measuring, namely lift, drag, pitching moment. Click off, make sure that you only have the differential pressure cell 1. You're going to also have the manual angle input checked, all the operating conditions, and then over for airfoil characteristics, make sure you set the airfoil chord length to 150 and check all the parameters listed under airfoil characteristics. After that, you're going to launch the communication between the wind tunnel and the computer by clicking on the computer icon, and you should be set to go. What you're going to do at this point is come to the force transducer, set the angle to the initial angle of attack, which should be 350, and then tighten the clamp that holds it in place. I'm not going to do it for the sake of the noise, but you come over to the wind tunnel, turn on the airflow. Again, I'm not going to keep it on due to the noise. You want to make sure that you set it to a wind speed of 25 meters per second. Adjust the temperature according to what the temperature of the room is. Make sure you set your angle speed to 350. You're going to come up, click on the clock icon, set your interval to ½ a second, which basically means 2 samples per second, and then you're going to record for a length of 30 seconds. And then after which you press this icon that says start recording data. And then you're going to record data for 30 seconds. Now, as that's recording, I need to mention one thing that I had forgotten to mention beforehand is before you start collecting any data, you need to zero the force transducer. So if you look right now, the force transducer, these are the digital readouts, gives you a lift, drag, and pitching moment other than 0. That need to be zeroed. You press and hold this until, for a number of seconds until it reaches 0. Make sure you do that before you start collecting data. So basically you repeat this step in terms of how you record the data. You're going to go ahead and increase this to 352 degrees. Go back and change the angle at the force transducer to 352 degrees. Something to keep in mind that you need to make sure you do is make sure that the wind speed stays at 25 meters per second. As you change the angle of attack of the airfoil, it disrupts the flow in the test section. In effect, it decreases the velocity. It might not happen for the first few between -5 and 5 degrees of angle of attack, but as you increase the angle of attack, you will see a decrease in velocity. So you're going to have to go and make sure you adjust that to keep it at about 25 meters per second. And then again, of course, at 35 meters per second when you eventually get to that. So you're going to keep recording your data, and then once you're finished recording all of your data, you go to File, Export to HTML, save it to the desktop, and you should see your data come up. And for example, that is the one data set that I just recorded, and you should see it for all the data sets you record. That concludes this instructional video. Again, when you export all the data, what you can do too is save the HTML file to the desktop and then open it up in Excel spreadsheet, and you should see it all open up where each number is in its own individual cell. And again, you should see all the data, all the parameters that you highlighted on the in the data window. Again, this thing calculates the drag coefficient, lift coefficient, and the pitching moment coefficient. Okay, that's it for now. That's the end of this instructional video. If you have any questions, you can of course ask your supervising professor for the class.